Hi, my name is Peter Andras. I'm a professor at Edinburgh Napier University. This is my lecture series on the evolution of complex systems. This is lecture 12, the evolution of science, and this is part 2 of lecture 12. So following the previous part of this lecture where we looked at how science emerges at the early stage, what are the roots and how it evolves. Here we will look at various aspects of how science evolves and changes. So we will look at specialization and the impact of specialization on expansion of sciences, how interpenetration between sciences leads to further expansion, how competition and selection works in the context of sciences, and we look at emerging sciences in general. So previously, we discussed about the science of theology and the range of practical sciences, early practical sciences, which lead to the emergence of modern sciences, both the modern version of theology as a science and the modern practical sciences. Now, the science of law is another early form of science, which is a practical science. It is rooted in the legal practices or customs of various areas and the systematic analysis of this. So the practical law, as it was applied in practice, differed from area to area. Different countries had different legal traditions. However, if you go back to Roman times, it was perhaps one of the early times when systematic organization of law and the laws of the land were provided. Of course, you can go back to the Sumerian times as well, where the first large volumes of written text are about the laws of the land and summarizing how various disputes are resolved and what are the principles for the resolution of these disputes. This practical law led to the emergence of the science of law, which is similar to theology in the sense that it is about the interpretation of legal practice, the legal text, and the elaboration on the top of these to derive further reasoning about how legal customs are applicable to particular complex cases. However, it is more variable than early theology because the law of land was more variable. I noted there were earlier cases in Roman times or in Sumerian times and in many other contexts where there were relatively large summaries of the legal knowledge describing how legal practice is done. However, in Christian times, the legal tradition and practices were more fragmented in Europe at the time when the science of law emerges in parallel with the science of theology. And of course, early universities were providing training and also further development of the science of law, which was the science that was taught next to the science of theology in early universities. Now, the science of medicine emerges around the same time out of practical anatomy, botany, surgery, and of course also theology, because that impacted how the understanding of the human body and human behavior worked. So the science of medicine emerges at the interface of these early sciences. And again, it brings in, to a good extent, experimental checks. However, you see that this is somewhat balanced in the sense that because many aspects of medicine were strongly impacted by theology, impacted by the way how, according to theology, humans work, and that had somewhat a limitation of to what extent experimental checks would be applied. However, overall, given the practical roots of the science of medicine, experimental checks were very important, and these validated the conclusions and reasonings in medicine. And of course, early universities, perhaps shortly after the adoption of law as a science and subject of study, they also adopted the science of medicine, where people would be trained in the science of medicine to become doctors at these early universities. Now, finally, philosophy was the other major topic of study at early universities. So if you look back to the ancient times, there were ancient schools which were focusing on philosophy and of course also on the practical aspects of the philosophical reasoning. So if you like, the philosophy is kind of pure theology, which is about the nature of reasoning, but how you can derive complex conclusions and complex lines of reasoning out of the existing knowledge. So it kind of goes somewhat free of the religion. Of course, at this stage, philosophy is still quite constrained by the context provided by religion. However, it also adopts a kind of some level of freedom from this religious context because it becomes a pure science of reasoning. Of course, interfacing with practical sciences meant that philosophy applies in this context, in the context of these practical sciences as well. And out of the practical sciences, it is only the science of law and science of medicine which are covered in early universities. Most other practical sciences are effectively covered in the context of the philosophy, which is the science of reasoning, including reasoning about practical science topics as well. Now, from this general philosophy, which emerges out of theology, the kind of pure science of reasoning, interfacing with the practical sciences and applying reasoning in the context of these practical sciences, and also somewhat bringing in the experimental checks as a checks of validation. So out of this philosophy comes out the so-called natural philosophy, which is the part of philosophy focusing on the practical sciences, like geometry, mechanics, alchemy, geography, as they were at that time, Middle Ages. So this is the interface of the kind of core, very theoretical philosophy and practical sciences as they are practiced. And this leads to the emergence of the natural philosophy, which is really the first experimentally validated science that is practiced at universities. So this is from 16th, 18th centuries university, perhaps slightly earlier as well, where the natural philosophy emerges as a main science of the practical knowledge and practical relevant knowledge. Now, around that time, printing is introduced, which allows the reproduction of written texts large amounts. So having this ability to produce large volumes of written text means that referencing this written text becomes much easier. Previously, books would be handwritten and copied from handwritten books. Now, that very long and time and resource expensive process is reduced to a much more resource efficient process, which can produce books in large quantity in relatively short time. And that means that the availability of memories for science communication expands hugely, and that expands the information subsystem of the sciences. So the science expands explosively at this time because it becomes more easily available for reference by a wider range of humans. Now, this leads to the expansion of the subsystems of the natural philosophy, like mathematics, physics, chemistry, astronomy. And this expansion happens through the emergence of specialist languages. And these specialist languages, if I use in mathematics or physics, define new subsystems of natural philosophy and new subsystems of science ultimately, with all of them having their own specific language. Now, ultimately, if you look at the environment of science, it is the society, and it is the further environment of the society. So science is about describing the experiences of society, the perceptions of the society, and also provides the reasoning foundations for the calculation of the actions of the society and calculations of expected impacts on the society's environment, and also the calculation of the right interpretations of the perceptions of the society about its environment. Now, in the context of this environment, of course, the different sciences, different subsystems of science compete. And the competition is happening in terms of how good are the descriptions of the environment of these sciences. How good are the descriptions of the relevant part of the society and society's environment, and which are the ones which make fewer contradictions or making fewer false predictions. So if you consider, for example, alchemy and chemistry, alchemy makes regular wrong predictions, while chemistry, even early chemistry, made much fewer, much less frequent wrong predictions. Or if you look at astrology and astronomy, both are about the study of stars. So the question is, which kind of study of stars is more relevant and more useful and more effective in the context of society? Astrology looks at stars and tries to derive information about individuals, about societies, about institutions in the society, about wars, about the best times for building things and so on. Astronomy looks in the same way at the sky, at the stars, but uses this knowledge in a different way. At the early times, astronomy used it mainly for supporting long-distance navigation, both on land and in particular on the sea. And it's very clear that astrology led many times to wrong conclusions, wrong predictions, while astronomy led much fewer wrong conclusions and wrong predictions. So in this way, the science which leads to better predictions about society and society's environment expands, while the others, which lead to more contradictions and more wrong predictions, more identity violations, they shrink and they cut back and they get reduced. This happened to both alchemy and astrology, while chemistry and astronomy expanded. Now, the ones that grow faster are the ones that are selected by the environment, so the ones which produce better predictions, better explanation of the society's experience, better reasoning for the society's actions. These are the ones which grow faster because there is more validated, experiment validated conclusions, so on which they can build further. So as I said, chemistry wins against alchemy, and astronomy wins against astrology in terms of using the information in the stars as a source of reasoning. Now, this also led to the development of specialist languages, and this leads to the development of various formalisms. So, for example, in mathematics and physics in the 17th, 18th century, each school or each major scientist had their own formalism, notations, concepts, and organization of these into reasoning, sequence of reasoning. But they were arguing about the same things, let's say, about how small distances can be calculated and can be used for calculations of integrals and derivatives. For example, in mathematics, they use different notations. And these various formalisms meant that the likelihood of misinterpreting or coming to a wrong conclusion based on a formalism that was not the common formalism of one scientist was much easier. Now, by the 19th century, there is a standardization of the mathematics formalism, and this leads to a massive expansion of mathematics, because this simplifies the language of mathematics. Instead of the many different valid formalisms, one common formalism is adopted, which allows to have much less wrong conclusions, much less wrong assumptions based on misunderstanding of notations, and this leads to expansion of mathematics. Also, it leads to interpenetration between mathematics and physics, and essentially establishing a uniform formalism in physics. And that leads again to an expansion of physics in the 19th century. So both mathematics, physics, and in fact all other practical sciences expand very much during the 19th century, thanks to this simplification and standardization of the formalism, first in mathematics and then physics and in the other practical sciences. Now, as we see in the previous examples, what we see is that there are fast expansions when the building of long descriptions of long derivations of reasoning can happen fast. And for example, this happens when the formalism gets standardized, when there is a standardized form of formal education introduced. So there are certain sources of this fast expansion. On the other side, there are also many cases of slow expansion when essentially these are the gap filling. So when there are small new knowledge is added, because there are always gaps in the scientific knowledge, whichever area you look at, and you can add these small gap fillings. Now, there are many small gaps, so actually the gap filling is still a very expensive part of science expansion, but happens at a slower pace than the fast expansion. Now, this can be seen, of course, from the perspective of Thomas Kuhn's the theory of evolution of sciences. What is the revolutionary evolution when it happens very fast? Because there is a way of expanding new descriptions. Now, the context of Kuhn, this is mainly about paradigm change, when the new paradigm comes up and the new version of science emerges from it. In the way how we discussed, it may also happen at technical innovations in science, such as introduction of formal education or the introduction of common terminology, standardized notation. But on the other side, you have normal science when you have the gap filling, the slower pace, but volume-wise still substantially large expansion of science. Now, the science has its, or the various sciences have their own language. So there are structures, constraints imposed on communications which define the sciences. Now, as science is organized, these structures lead to institutional organization in the context of science. So, essentially, these institutions apply further constraints on scientific communication. So, for example, conferences may accept certain lengths of communications papers of certain lengths in some particular range of topics, possibly quite narrow range of topics. Or if you look at academic departments in universities, they define themselves by defining their boundaries, defining the range of topics that they cover. similar scientific societies or scientific journals narrow the range of topics that they cover, narrow the range of communications that they accept for publication, or in the case of societies or departments, communication that they accept as valid communications within this society or within this department. So this institutional organization of science, of course, may also lead to the questioning of identity and existence of certain parts of sciences. So effectively, by defining all these institutional organization units, there is always the questioning of the existence and identity that defines these institutions. For example, is it all right to have a department of physics? Or is that too broad and you should have a department of biophysics? Or is it all right to have a general journal of mathematics? Or should you rather have a mathematics journal specialized for certain branches of pure and applied mathematics? And so on. Now, as a result of this institutional organization of science, there are new subsystems in sciences that emerge, and these new subsystems give rise to new branches of sciences and ultimately potentially to new sciences. So these are the interfaces between the sciences where, as we discussed earlier, the rules change, the boundaries change, and the questioning of the interface system leads to the new interface science, a new identity. So, for example, if you look at more recently, the interface between sociology and the computation analysis of social data, especially since social network data and mobile network data is available for scientific analysis. There is a lot of data-driven analysis of social behavior. So on the boundary of the kind of data analytics and sociology emerges the area of computational sociology, which is distinct from the computational modeling of social processes. However, interfaces with this as well. And currently, right now, we can see the emergence of this data-driven sociology or computational sociology as a new branch of sociology, which is likely to expand in the future and become a new part of sociology and possibly a new science in its own right. In the same way, there are many other interface sciences. Think of theoretical biology, think of, for example, biophysics, or physical chemistry, or with many other areas where interfacing with, in particular, mathematics, data science, physics, chemistry, of various other sciences leads to interface sciences and emergence of these sciences. There are also specializations of other sciences. So if you look at in general other sciences, other than the discussed sciences of practical driven sciences, out of philosophy there is a branching off of the social philosophy, which is the application of philosophical reasoning to social processes and social phenomena in general, which leads to the science of society. And many branches of the science of society, for example, economics, political science, sociology, or psychology, which is the science of the individual communications by humans and inside of humans. Another area that branches off is the humanities. So this is branching off on the interface of philosophy with arts in general, like literature, music, theater, film in more recent times. And of course, this also integrates some other sciences today, which are at the root of all sciences, such as philosophy and law. Of course, perhaps you may count here theology as well. And these sciences go further and become much more theoretically driven at their end. So there is science of the theory of writing or literature. It's about how does the written text work? What is the role of the author? What is the role of the audience? And similarly, there is a theory of art, which is about how does art work. And again, these go back perhaps to the late 19th century, early to mid 20th century, thinking about how humanities work, and in particular how art, in particular painting, how music and writing work, and kind of understanding of the mechanisms of how communications work in society. Another area of other sciences is the kind of very practical driven sciences, which are the areas of engineering. So this is the various interfaces of natural sciences with practical sciences. So think of construction engineering, mechanical engineering, and chemical engineering, and so on, electronic engineering, which are all practically applied areas of sciences, which is about building, constructing things, and again, these expand very much through the interfacing with physics, mathematics, chemistry, mainly, which provide the input to come up with new technical solutions to a range of technical problems. If you look at today, for example, 3D printing, which really overcomes many technical problems of how materials can be manufactured into certain shapes and forms that deliver functionality. There is a huge potential future expansion from this in the areas of engineering, and we have seen this huge expansion of engineering in the last perhaps 1.5 century, starting really in the middle of the 19th century and then carrying on over the 20th century, and today, the 21st century, lots of innovations in engineering, and very fast innovations in engineering. Think just, for example, of the engineering related to travel and transportation, which moved in a relatively short time from the horse-driven carriages to the rockets that can go to the moon or to Mars, and the very high-speed airplanes, and also high-speed ships and cars. Finally, looking at medical sciences, of course, we discussed about medicine. However, the science of medicine turns into a collection of medical sciences, which are the various specializations of medicine, for example, neurology, dentistry, cardiology, dermatology, and many other specialist areas of medicine, which expanded in their own right and became parts of the medical sciences themselves, being separate sciences. And again, there is a lot of interfacing with physics, chemistry, biology, and of course also with mathematics and data analytics, which leads further expansion of these medical sciences. And finally, let's consider kind of new sciences. There are mainly computer-related sciences. So computers, as we discussed, are about processing data. So this is the science of data processing. But going beyond that, this is the science of methods of data processing, how data processing works, how data processing can operate, and really interfacing with mathematics and physics and to some extent chemistry. It's about science. It is development of science of describing and solving problems. And the information science is kind of wider science of information system, of how information is collected, processed, stored, and used. So these are perhaps the newest areas of sciences, and of course computer science interfaces with all other sciences. The data science, as we mentioned, is on the interface between computer science and mathematics and many other sciences, and impacts in this way the development and expansion of many other sciences. Right, so to summarize, we discussed about the memories in science, how the information processing happens in science, continuing the previous lecture. And then we discussed about a range of particular sciences. First, the older sciences that were taught at old universities from the Middle Ages onward, like law, medicine, philosophy, and then natural philosophy, which descends from the philosophy on the boundary of philosophy with practical sciences. Discussed about interpenetration and interface sciences, how this leads to changes in sciences, how branches become specialized in natural sciences and lead to the development of new sciences. And then we discuss about competition between various sciences and the selection of sciences in the context of this competition. In particular, we noted the competition between chemistry and alchemy, and the competition between astronomy and astrology, which compete for the science of interpreting and analyzing data about the stars in the sky. Then we discussed the role of simplification and expansion, in particular in the context of mathematics and physics, but we mentioned that this led impact into many other sciences, in fact in all other sciences, by providing a simplified, standardized language to describe concepts and reasoning, which leads to rapid expansion of these. And then we discussed the range of other sciences and also new sciences, such as social sciences, art, humanities, medical sciences, and we concluded with this brief discussion on new sciences, such as computer science and information sciences. Let's see a few questions. Is it true that the sciences of medicine and law emerge independently from theology? And well, the answer to this is that yes, to some extent. However, the interfacing with theology was very important in both cases. So on one side, law deals with deciding on solutions when dispute emerge related to legal status of things, be them goods, land, and so on. However, as law emerged, the role of theology is important in that context, although law is about synthesizing the legal customs. The legal customs are, of course, influenced by theology, what God may think and what God's view might be. In the same way, medicine emerges from the practical knowledge of surgery, botanics, and other related areas. However, again, theology has a significant impact on medicine because the human body, the human mind, these are defined in the context of theology. There are constraints imposed on what you can do and how you can interpret things about them, and those were, of course, impacted on medicine as well. So overall, while there appear as sciences around the early universities, when the early universities are established in Europe, and they have practical foundations in terms of treating disease and treating legal disputes, there is significant impact on theology of both of them, so they are not necessarily independent of theology. Second question, is it true that philosophy emerged as the interface of theology and practical sciences? And indeed, that's where philosophy is emerging, perhaps to some extent at least. Clearly, philosophy is emerging as a kind of science of reasoning, which kind of detaches itself from the strong theological constraints, or does not get rid of them fully, but also it applies itself to the reasoning in the context of practical sciences. In that sense, indeed, philosophy emerges at this interface by detaching the study of reasoning from theology and also applying it in the context of practical sciences. Next question, is it true that natural philosophy emerged at the interface of medicine and philosophy? And the answer is no. Natural philosophy is really, it is emerging at the philosophy's interface with practical sciences. So, well, the philosophy covers practical sciences, but that interface is where the branch, the specialization of the natural philosophy emerges and detaches from the kind of more pure philosophy, which stays to deal with the science of reasoning. Next question, is it true that astrology competed with mathematics? Well, and to some extent perhaps yes, but really astrology competed mainly with astronomy. Not that much in terms of the conclusions, but rather in terms of using of data or information about the environment. So both astrology and astronomy use the information about the stars for different purposes. So in that sense, astrology competed for the use of that knowledge and that information with astronomy and not with mathematics. Next question. Is it true that alchemy was outcompeted by chemistry because the former produced more contradictions, reducing its expansion capacity? And yes, this is indeed true, because alchemy aimed to turn everything into gold, and that led to many contradictions, making difficult its expansion and effectively leading to its shrinking. While on the other side, chemistry, which again deals with how materials interact and what can be produced from these interactions of materials, led to better predictions, fewer conclusions, and as a result, it expanded and took over from alchemy the understanding of materials and operations with materials. Next question, is it true that major expansion of mathematics happened before the uniformization of mathematical terminology? Now, clearly there was expansion of mathematics before the uniform terminology emerging by the 19th century. However, this uniformization of the terminology led to a very massive expansion of mathematics because mathematicians started to speak the same language, eliminating or limiting very much the chance of misunderstanding and wrong conclusion, and also making it much easier for each other to read their derivations of reasoning. So that led to the major expansion of mathematics in the 19th century. Next question, is it true that social sciences developed as descendants of social philosophy? And yes, that's what you can say. So philosophy, of course, included the natural philosophy. It also included social philosophy, which was the application of philosophy to social phenomena, and it turned into science of society and ultimately led to the emergence of the range of social sciences that we have today. Finally, is it true that computer science is a new science of problem and solution formulation? Is it true that it can be seen as a new kind of philosophy? Well, indeed, computer science, it is the science of problem solving, solution formulation and problem formulation, and the mapping of problems onto solutions in a very abstract sense, but also in a very practical sense in implementing the abstract programs that process data and lead to these solutions. And in a sense, you may say that this is a new kind of philosophy because it is a very theoretical understanding of how reasoning works. So, like philosophy as the science of reasoning and the application of the science of reasoning to a very wide range of problems leading to natural philosophy, social philosophy, and the various sciences emerging from these. Computer science goes back to the foundations of this and looks at how reasoning works, how the problems can be stated, and how the solutions to these problems, which are effectively how the reasonings that lead to conclusions from the problem, can be stated. and looks at this in a very, very abstract sense at the core of computer science, which is the theoretical computer science. So you may see this, indeed, as a kind of new kind of philosophy, which is far more abstract than the previous philosophy, and it also far more rigorous, much more grounded in advanced formal mathematics. Thank you.